All right, so from our last video, we're going to continue this solving this problem involving this triangle where we have two sides. In this case, it's 18 centimeters and 8 centimeters, and then there are opposite angles that are involved. The one we're trying to find, angle C, I'm going to let that be called theta. I'm going to leave it as angle C throughout the solving here, though. But that angle, that theta, at least tells us, hey, that's the one we're going after. And then we also know that this other angle here, angle A, is 68 degrees. Let me get A back in there. That must have gotten erased. And now what we can do is use our good old algebra, in this case, cross multiply and divide, and then some trig stuff to simplify. Have your calculators ready to go. Make sure your calculator is set to degrees. So when we do this, it's much simpler and quicker. All right, so here's what I mean. We're going to cross multiply. We're going to take 8 multiplied over there. We're going to take 18 multiplied over here. So we end up with this. 18 sine C is equal to 8 sine 68. Again, make sure that your mode in your calculator is set to degrees. And so when I do this, on the right-hand side, I'm going to have 8 times the sine of 68. That gives me 7.417. That's just a numerical amount. And now we're going to divide both sides from there by 18. I guess I won't do that yet. We're going to go 18 sine C. Let's stay algebraically sound here. So then we're going to divide both sides by 18. I'm not going to show that because I'm running out of space, if you don't mind. So sine C is going to be equal to this 7.147 divided by 18. And that gives us this 0.412. I'm going to go ahead and take it out to 4 places on this one. And so now if I want to find that angle measure, remember we're seeking angle measures with trig functions. We have to do the inverse function. So I'm going to take the inverse function of this. So I'm going to go inverse sine of 0.41208. And I get that to be about 24 degrees. So C in this case would be about 24.3 degrees. That's not a very nice 2. Let me do that. That's ugly, but let's just write it in up here. So now we know that this angle is 24.3 degrees. So we could actually continue this, and if we wanted to, we could find the measure of angle B, and then we could use the law of sines again and find the opposite side of angle B if we wanted to. That's actually called solving the triangle. I don't know if this text necessarily does that, but just know that that also can happen within these problems. All right, so let me get something else to write on here. This will take just a second. Hopefully my computer will allow me to do this. I'm going to go ahead and add in here another page. And if you want to, you can speed through this part of the video so you're not sitting here waiting for my computer to get going. And let's actually look at example 1. We'll use page 485. And this time we'll be given 2 angles, and we'll use the first one there, example 9, find BC. I'll set that triangle up here. Now we're going to be looking for a side length. So a little bit different than the one that we just did here in the previous example. This is from page 485. And this is example, I think it's example number 9. This would be problem number 1. And so it's saying find BC. Okay, so that triangle looks something like this. And we know this side length is 12 centimeters. This is our unknown. I'm going to call it little a because it's opposite angle A. We know this angle down here is 38 degrees. And then we know that angle B is 44 degrees. Okay, so because we have two angles and a non-included side, remember that from your geometry days. So we have angle, angle, side, so to speak, and we're looking now for that other side. We can set up this relationship because we have angles and opposite sides involved. And so we can use our law of sine. So we say this, the sine of B is to 12 as the sine of A is to that side BC that we're looking for. So now we can sub into that, those angle measures. So we can actually just go right to the sine. And if you want to do it that way, you don't have to write that first step there. You can write sine 44 is to 12 as the sine of 38 is to A. Okay, now because we have proportion again, we can do this cross multiply process, and then we would be solving for A. You're going to get pretty quick at these, and if you've probably seen this before because you had it last year, it probably should be reviewed for you. You would have A sine 44 is equal to 12 the sine of 38. And some of you guys know like little shortcuts and blah, blah, blah. I don't show shortcuts because I don't believe in necessarily shortcuts or tricks or anything like that. If you want to create your own little shortcut, you go right ahead. I'm going to show it in my work step by step so that it's something that is clear to all who would necessarily look at this. All right, so then I'm going to divide both sides by sine 44 to solve for A. And so A is going to be equal to, so that cancels there. And now you can just type it in your calculator. There's a million ways you can type this in your calculator. Be careful using your parentheses. I'm going to write mine in as 12. I'm going to go left paren. And some people say you don't have to do that. Maybe not. I'm going to go ahead and do that. I'm going to go right paren. So I'm going to set all of that off at the top there. That is equal to, I get 7.38. And now I'm going to divide that by, and I'm going to put this in parentheses as well, just so it's included, sine 44, double paren there. And I get my length on the other side there to be 10.6. And lo and behold, that's what the textbook gets as well. So this would be 10.6. Is this in centimeters? So make sure you put in your units, guys, when you're solving these problems. Okay, so there is a methodology. There is going to be some that are application problems. So you're going to have to set those up by picture. I'll leave that to you to do. That's a big part of this whole thing. We'll tackle any problems you have with that in office hours if you have questions on how to set those up. In the next video, I'm going to show you guys what's called the ambiguous case with law of sine. So there is an issue where you could possibly end up with two solutions because of how sine is set up within. And if you remember your geometry, when you do some proving, side-side angle is not a legitimate way of proving two triangles congruent, only in certain cases. And so that creates also an issue here with this law of sine, or what they call the sine rule. Okay, I'll see you guys in the next video. Good work.